Hi guys, my name is Vinipal, and right now we're going to be doing section 3.3, which is rational inequalities. And first off, I'm going to take you to an example, which is f of x equals x minus 10 over x plus 3, and we have to determine when this function is less than 0. Now, in order to do that, we have to factor it, but normally this is already factored, so we'll go straight to the x-intercepts and the vertical asymptotes. And the first step is basically finding them. So looking at the equation, I can see that the x-intercept is 10, and the vertical asymptote is -3. Alright, since we have those values, we can just go straight to the English chicken theorem, or commonly known as the interval test. So we would use that, and we go over here. And right now, I've already made the chart for you guys. Right now, we would just put the values in. Before we do that, we have to substitute values that are in between these numbers. So we could use negative 100, 0 between -3 and 10, and another positive 100. Okay, so in this case, we would get a negative over a negative. The reason I'm doing a negative over a negative is because of the equation I substituted in here. So in that case, we would get a positive. Here we would get a negative over a positive. In that case, we would have a negative here. And here we would have a positive over a positive, which would give us a positive. Now, this equation is telling us to determine when this function is less than 0. As you can clearly see here, between the intervals -3 and 10, the function f of x is negative, which means it is less than 0. So now that we know it is negative between -3 and 10, we could just go straight to the therefore statement, which we would make, therefore, f of x is less than 0 on the interval -3 and 10, and we would use square brackets just to tell whoever is reading up the equation that these are also included. So this would be your solution. Alright, so here we have a actually advanced type of question. It's also still a rational inequality, but right now this is quadratic over a cubic. Now what we're going to have to do in this case is we're going to have to factor both the numerator and the denominator. And in that case, the quadratic would be very simple to factor, where you would get x minus 2, x minus 1, over x minus 3, bracket 5x squared plus 7x minus 6. Now what I did with the denominator, since it is a cubic, I used the factor root theorem to determine one root, which was x minus 3. And from there, I just factored the quadratic, which the final factored equation that I got was x minus 2, x minus 1 over x minus 3, 5x minus 3, and x plus 2. Now, since I have the vertical asymptotes and the x-intercepts, I was able to substitute this into the interval test. Now, I labeled all the points. I've also already done all the work. And g of x, as you can see, we're supposed to be determining when it is greater than 0 or equal to 0. And in this case, the interval test shows that g of x is positive 1, 2, 3, 4, 4 times in the intervals of negative infinity and to negative 2, to negative 2 to 3 over 5, 1 over 1 to 2, and 3 to positive infinity. So now that we have those intervals, we just need a therefore statement where we would take it here. Therefore, g of x is greater or equal to 0 on the intervals. On the intervals -2, negative infinity, 3 over 5, and -2. And 1, and 3 and infinity. Therefore, this would be your final solution.